Now, NumPy can deal with n-dimensional data. As I told you, dimensional array. You can see with everything can be dealt with the n dimension. So what do you mean by n dimension? See, there will be something called as one dimension array. There will be two dimension array. There will be three dimension, four dimension, five dimension. Like this, you will be having the n dimension. So the flexibility of NumPy is it can hold the data in n dimension. Okay. Now, what do you mean by n-dimensional? First, let's see this. What is this n-dimensional? First, what is one dimension? I will give it as one dimensional array. And there is again two-dimensional array, three-dimensional array. In a simple terminology, guys, if you take some numbers, okay, and you arrange them in one direction, that is considered as one-dimensional array. Whenever you come across the word dimensional, that means you are arranging the numbers in one direction. That can be anything. It can be top to bottom or left to right, anything. Okay, so it is like one dimension means arranging the numbers in one direction. Arranging the data in one, or I will give it as numbers. Numbers in one direction is referred as one-dimensional array. Now it will be something like this. I can use it like 11 and I can say that 32 and 18 or 40, 27 and 56, something like this. Okay. Now this is arranged in one direction. Okay. This, if you look at the direction, it is from left to right. This is the direction. Okay. This is one direction, left to right. Okay. Now in this is one dimension. Okay. Now this one dimension is also referred as, now this is very popularly called as one-dimensional array is also referred or called as, vector. Now, please remember this word vector, because we will be using this word term a lot in the future till till our generative AI, we will be talking about embeddings, and there the vectors we will be using. So vector is the term over here. Now, if you are having two dimensions, let's take it two-dimensional array. So it is nothing but the arranging the data in two dimensions. I can say it as two dimension or two direction is referred as two dimension array. Okay. Now here it is like two direction. Here we are having one direction, so we will be having two direction. Now I'm just taking this one and I will add some more over here. This is nothing but the two dimension. Here I will give it as 12, 23 and maybe 17 and 37 and 46. And here I will give it as 87 and 30, 40 and 22 and 16. 19. I'll give it as 21. Like 45, 90, 97, and 16. So this is an array. So this is in two direction. This is called as two direction. Okay. Now, I already explained you this. If I'm taking this one. Okay. This is a two-dimensional array. Now, these are called as columns, or we call it as features, and we call it as like entity, and also we refer it as a variable. Now, this variable is different from our programming term variable. This is, again, we are talking about the entity in the tabular data. Okay. Now, this one we call it as the rows. Okay. We call this one as rows, or we call it as like records, or we call it as samples. Now, please remember all the three. In this, you have to remember this one and this one. Features and columns. Columns, it's okay, but features is a term we are going to use it a lot. Okay. Now, this is about our two-dimensional data. Okay. Now, just a minute. This is a two-dimensional data. So if you count, how many rows are there? 1, 2, 3, and 4 rows. How many columns are there? 1, 2, 3, 4, and 5. Now, 4 rows and 5 columns is called as the shape. Okay, this is like 4 rows and 5 columns. We call it as shape. Now, whenever someone asks you about the shape, what is the shape? That is nothing but they are referring to number of columns, number of rows and number of columns in the array. Okay. So now I will just put on over here 4 rows and 5 columns over here. This is actually, we call it as a shape. 4 rows and number of rows. Always rows should be first, followed by the columns. Okay. Now, and this two-dimensional array is also referred as a two-dimensional array is also referred as matrix. Okay, it's very popularly called as matrix. Okay. Now, if you observe it, guys, this is my one-dimensional data. This is my two-dimensional data. Okay, now I will just make a room over here to put on one more important component. This is one-dimensional data, and this is two-dimensional data. Okay. Now, this is a collection of numbers in one direction. This is collection of numbers in two direction, right? So now, next one is, I will say it as a single value. Okay, a single value, we will call it as scalar. Okay, usually if we have a single value, we call it as scalar. Scalar is nothing but single value without any direction. Now this single value will not have any direction. So one dimension means one direction, two dimension means two directions. But when it comes to the scalar, it will not have any direction. So any single value is considered as, like you can take it as, I'll give it as, like I will give it as 12 is a single value. This is considered as a scalar, a single value which is considered. Now these terms are interrelated. First one is scalar, second one is one dimension, two dimension, and three dimension. Okay, now I will just establish the connectivity. This is a scalar. Okay, this is a scalar. Scalar and one dimension, in a sense, a group of scalars arranged in one direction is called as a vector, right? Can I say that? Yes, we can say it. A group of scalars arranged in one direction, we call it as a vector over here. So this is a vector. Now, what is the two dimension? A group of scalars which are arranged in two dimension is called as two dimension, or two direction is called as two dimensional array. Now I'm defining this in terms of scalar.
Or we can call it matrix also for two dimensions.
Yeah, that's what I said it right here.
So scalar in two dimensional is matrix.
Yes.
Okay.
Two directions. Okay. So here in terms of scalar, we can define the one dimension as a collection of scalars arranged in one direction. We call it as vector. And if there is the same scalars arranged in two direction, we call it as matrix, two dimensional, or we can call it as matrix. Okay. Now in terms of vectors, so if I want to define the two dimensional array, I can say that it is a collection of vectors which are arranged in one direction. Now you see this. This is a vector. This is a vector. This is a vector. This is a vector. And all are arranged in one direction. So you can also say that matrix is nothing but it is a collection of vectors which are arranged in one direction. Okay. Now we know that collection of scalars is one dimension array or vector, or collection of vectors in one dimension, we will call it as two dimensional or matrix. Now we can, what is three dimension? Three dimension is nothing but collection of two dimension. Okay. Now I will take this one. This one, let's take, sorry, this one. Okay. Sorry. I did it somewhere here. I will put it on over here. This is one matrix and this is the another matrix. So now try to understand, guys. Collection of scalar in one direction is vector. Collection of vectors in one direction is called as matrix. Collection of matrix over here, we call it as three dimension. You can call it as three dimension over here. Now I can put it on like this. I can give it as this way. This way we can give it. Okay. This is nothing but three dimension. Okay. This. Three-dimensional array. Here I'm putting down, this is a 3-dimension. Now again, group of 3-dimension or collection of 3-dimension is considered as a 4-dimension. Okay, now we got the basic idea of different types of arrays. Now let's see that how to create these arrays. Okay, then afterwards we will see that how to extract the values from the arrays. So 1 second, guys, let me have some water. Okay.
Now, we know that now the fundamentals of the array. Now, how to create this NumPy array? Okay, so total there are 5 different ways of creating this NumPy array. Okay, different ways of creating NumPy array. One is called as traditional way. Okay, second one we will call it as homogeneous array. Next one is diagonal array. Third one is random number. Okay, these are the 4 ways. Total we are having 4 different ways, and one more is there, I missed it out, which we call it as numerical way. Total 5 numerical array. Okay, all are numerical arrays only, but this is homogeneous array, diagonal array, numerical only numerical array, and we have these are the 5 different ways of creating the array. Okay, now they are having their own significance. Okay, all of them is having their own significance. Now let's go ahead and create one after the other. So when you are dealing with traditional array, we are going to use the array method, or we can say it as array function. Now what you have to do it in this is you have to give the data, and that data should be in the shape. Now you know the shape. What is the shape? That is number of rows and number of columns. Okay, now you have to give the data in the form of shape. We can't directly give a shape and then we will ask them to design the array. No, you have to give the data along with the shape. Okay, that is what it will happen over here in traditional way. There is something called as homogeneous. Homogeneous way means here in this you don't need to worry about the data. Okay, we provide the shape and it will generate the array. Now for example, I wanted like 4,6. Now shape is 4,6, that is 4 rows and 6 columns. Okay, I'm talking about here 4,6. 4,6. Okay, we have 4,6. Now that is nothing but 4 rows and 6 columns. All you have to do it is this shape. And what this homogeneous will do is like it will generate the data based on their default values. For example, if I have a method called as over here I'll give it as ones. Okay, ones. So in this, you give the shape. That's it. So it will generate the array with all ones. Now you give the zeros, and it will generate the, you will give the shape in the zeros, it will generate the array with all zeros. That is what mean by your homogeneous array. Homogeneous array means it will generate the array with a homogeneous value, single values. Okay, now of course these have to be used with numpy, otherwise it will not work. Okay, I will show you. And there is one more is there, sorry, diagonal array. What do you mean by diagonal array? Means you will be having a diagonally. Okay, in the diagonally you will have all ones. Before, above the ones, above the diagonal values, above you will have zeros, and below you will have zeros. So it will be like I. You have to give the I, and you will get, like, suppose if I am giving 3 as a shape, 3 rows and 3 columns. So what will happen is, I will give it as 1 0 0 0 1 0 0 0 1. So this is my diagonal ones. So diagonal array will have in the middle row, sorry, middle diagonally, it will have all ones. Above that you will have zeros, and below that you will have. Usually it is pretty effective with the square matrix. Square matrix means the number of rows and number of columns are same. Okay, then it is called as this is very effective when you are dealing with the square matrix. Then only you will get the middle values as one. Before that and after that you will get it all zero. Now, next one is numerical. Numerical, we have it like a range, and there is one more is called as linspace. A range, and we have the linspace. Now in this, now if you remember, if you take it, this one we gave the values along with the values should be in that desired shape. Whatever shape you wanted, you have to give it. Then it will create an array. In this case, what it will do is, like, it will take the shape. You have that choice of giving the shape, but you don't have the choice of giving the numbers. Okay, it will create with all the ones or all the zeros. And diagonal array is nothing but you will be giving the shape like 3 comma 3 or 4 comma 4, and you will not have the choice of the numbers. The middle value will be all ones, and above and below will be zeros. So in this all, especially homogeneous and diagonal, we have the choice of giving the shape, but we don't have the choice of giving the values. In the numerical, you will have the choice of giving the number range. You can give the number range, and it will generate the array with one dimension, only one dimension. Okay, so here we can provide the number range. And what now if I take it like 1 to 50, so it will generate the values from 1 to 49, and all will be in one dimension. Okay, now in this one linspace, here we will give the starting value and ending value, and how many values you have to generate in the middle. Okay, now I'm going to show you this, not to worry about. So like, for example, usually if I say it 1 to 10, so it will be usually we will say that how many values are there, means you will say that 1 to 10, it is between 1 to 9, the values are there, right? So, but here what we can do it is, you can give the starting value as 1, ending value as 10, but in between that you can generate n number of values. That is, you can give it as 50, means it will generate 1 to, in 1 to 10, in between you will generate the 50 values. Okay, that is what it will happen, linspace. Okay, now there is something called as random. Now again, this is, we are having rand, that is random dot rand. Okay. Now there is one more will be there, random dot rand n. Okay. There is something called as random dot rand int. Okay. And there is one more called as random dot choice. Like this. These are the different arrays we can create it using the random. Okay. So these are the 5 different ways of creating the array using the Numpy array, different methods.